All right, today we're going to look at how to solve equations using our logarithms. And in the first example, we have 25 is equal to 10 raised to the x minus 1. And the variable that we're trying to solve for is in the exponent spot. So we've got to do something to get it out of that exponent so that we can isolate it. If you recall earlier in this packet of notes, we looked at evaluating something like log base 2 to the 6th. And we said, well, what does that equal? Okay, well, we set it equal to x. Okay, and then we said 2 to the power of x. We wrote it as an exponent, so we said 2 to the power of x equaled 2 to the 6th. And the bases are now the same, so x is equal to 6. So essentially what happens is when you take the log base 2 and that log base matches the base in the of the exponential problem, those essentially cancel each other out and x is equal to 6. So when I'm going to use that concept when I solve and I want to get the exponent here. So it's a base, it's in exponential form and the base is 10. So that means I want to take the log base 10 of both sides. Now we know that the log base 10 is the common log. So we can just say log, take the log of both sides. Log of 25 is equal to the log of 10 to the x minus 1. Okay, remember that this is a base 10 when you don't see a number there, right? So when I go to evaluate this, on this side, this log base 10 and this 10 are going to cancel each other out, and you're just going to be left with the exponent x minus 1. On the other side, we're going to need to get a calculator so that we can evaluate the log of 25. Just like you did before, you're going to punch in 25. You're going to hit your log key, and I get a value of 1.398. I'm going to say 1.398. Make sure I did that right. Yeah, 1.398. Okay, and then I'm trying to get x by itself, so the last thing I'm going to do is I'm going to add 1 to both sides, and my solution there, x is going to equal 2.398. Okay, make sure you line up your decimal point here when you add 1. Okay, here's another example B. We've got a base of 10, so we're going to take the log base 10 of both sides. In this case, that's just a common log. So I would take the log of 10 raised to the x plus 1, and that's equal to, I'd have to take the log of 50 as well. Whatever you do to one side of an equation, you have to do the exact same thing to the other. Okay, when I take the log of 10 to the x plus 1, because this is a log base 10 of 10, those are going to cancel each other out, and you're just going to be left with x plus 1. On the other side, you're going to take the log of 50. My log of 50 is 1.699. I'm going to round it to the nearest thousand. That's what it says in the directions. And I would subtract 1 this time to get x by itself. So in this case, x is going to equal 0.699. Okay, that's how we're going to solve equations when we have the log. We have it in exponential form like that. Okay, now these are not in exponential form. These are in log form, right? So if it was in exponential form, we took the log of it, took the log of both sides. If it's in log form to begin with, we're going to write it in exponential form. So we're going to go to the other form. This says log of 3x minus 2. You don't see a base there, so we know that the base is 10, and the exponent's always found on the other side of the equal sign, so 10 to the second power is equal to this 3x minus 2. Okay, that's an equation we can solve. 10 to the second power is 100. And then from there we would add 2 to both sides. So 3x is equal to 102. And if I divide by 3, x is equal to 34. Okay, that one comes out even. I don't have to round that. X is equal to 34. Okay, if I look at letter D, it says the log of, there's no base here, so we know that's a base 10. So that's raised to the third power is going to equal this 7x plus 6. Okay, and from there we solve for x. So 10 to the third power, 10 times 10 times 10 is 1,000. Okay, how would we solve that from there? We're going to subtract 6 from both sides. So we get 994 is equal to 7x. And if I divide 994 by 7, we get 142 is equal to x. Okay, again, that came out nice and even for us. We don't need to round. All right, the next one. These, you notice, these are in log form, but it's not the common base log, it's natural log. And when natural log or ln is seen, what's the base of that? Okay, we know that's a base e. You don't see the e written, but we know that's base e. So we're going to say e to the fourth power equals 2x plus 3. Now remember, that e expression is a lot like pi. Pi has a value of 3.14159, and that decimal keeps going. Well, e is similar to that. E has a value of 2.71 something something. It keeps going. Okay, so you have a key on your calculator that evaluates your e. Remember, you need to put your exponent in first and then hit your e to the x key. I'm going to go ahead and round that. That's 54.598. And that's equal to this 2x plus 3. And now we're going to solve by subtracting 3 from both sides. So that's going to be 51.598 is equal to 2x. I divide by 2. I get a value of 25.799. Sure I did that right. Let me see, I've got e 4 to the x minus 3 divided by 2. Yep, I get 25.799. Okay, again, this one, natural log is involved, so we know that's a base of e to the second power equals 3x minus 1. E to the second power would be 7.389 is equal to 3x minus 1. What's your next step? We're going to add 1. We get 8.389 is 3x, and then divide by 3. X is equal to 2.796. Okay, and then your last two here, we have e involved. Kind of like the base 10 was the common log. Okay, when e is involved, we're going to use the natural log. Okay, when 10 was the base of the exponent, we use the common log to undo that. When e is the base, we're going to use the natural log. So I'm going to take the natural log of both sides of the equation. And because natural log is a base e and the base of the exponent form was e, these are going to cancel each other out. X plus 2 is equal to, I can evaluate the natural log of 8 on my calculator. I get 2.079. Okay, and then I want to subtract 2. So I'm going to say x is equal to 0.079. So I'm like 2. Okay, and then lastly, the e is not by itself yet, so we don't want to take the natural log quite yet. But we can isolate that e to the x by dividing by 1.5. Then I'd have e to the x is equal to 18. 27 divided by 1.5. Okay, now that we have e by itself, we can now take the natural log of both sides of the equation. Those e's will cancel out, and x will be equal to I got 2.890. Okay, and that's how you solve equations using your logs and your natural logs and your common log. Okay, so there's a worksheet for you to work on.